Hello to all the HubLE audience. My name is Niloufar Ansari. I'm a postdoc at Monash Institute of Pharmaceutical Sciences in Australia. I'm also an editorial board member of HubLE Meet the First Author Committee. I'm here today for an edition of Meet the First Author with Dr. Christina Møller Andreasen from Odense University Hospital and the University of Southern Denmark. We will be talking about her paper titled The Generation of Enlarged Eroded Pores Upon Existing Intracortical Canals is a Major Contributor to Endocortical Tuberculization, which was published in the Bone Journal. So welcome, Christina. To start with, can you please tell us a summary of your work and how it fits into the big picture of the field?
Yes, I can, of course. And thanks to you, Neil, and to HubLE for giving me the chance to take part in this interview. It's a pleasure, really. Well, to take a little step back, we have in our lab focused quite a lot on bone remodeling and how it's affected with age. Trying to figure out, especially also the cortical porosity, how is that, why is it increased with age? We can see it is, but we have tried to figure out the remodeling events behind this. And from some of our previous papers, we have actually developed a classification system to look for the cortical canals. That's what we see it in 3D, but when we look in histological section, it's a 2D cross section. And to do a proper investigation on what is going on with aging, we wanted to make this system to classify what type of pores do we actually see, or what type of remodeling events do we experience in bone. And we know from numerous studies that endocortical remodeling starts with resorption. It goes into the reversal resorption phase, and then if everything goes good, we should end up with formation. But it seems like we have a problem or a missing coupling between the reversal resorption phase and formation. And in our previous papers, we have found that especially in the cortical bone, we would have an accumulation, in fact, of enlarged eroded pores, which are sort of, you could say, trapped in this resorptive stage, not able to go through to the formation phase. So we will keep these large pores. And in this particular study, we wanted to address, can we then see a difference when we look at the periosteal half versus the endosteal half, to see if this tuberculization could be due to a change in the remodeling events. So that was actually the main topic of this paper. And if I should say a little on what we did, we utilized fibula specimens from patients, both men and women, having a reconstructive surgery of their jaw. They used some fibula bone, and we had a leftover piece for our analysis. And first of all, we did a micro-CT scanning of the entire bone, and we were quite detailed or precise on the angle of the scanning, so that we were able to cut the sections with the same angle, so we could have the 3D structure, and then we could go to a certain level and analyze the 2D section at the same spot as the image, one could say. So we did a lot of measurements. We measured pore area, pore diameter, osteoid diameter, and all that in order to characterize the type of pores. And we used the classification scheme as previously. Also, it's also shown in the paper. You can have a look later on if you're going to read it. But basically, we found with the micro-CT scanning, we found, as expected, a higher canal diameter. Also a higher porosity in the industrial part compared to the, compared to the periosteal part. But why is it so? We could see from the classification of the pores that we have, in particular among the larger pores in the industrial half, many active or pores in an active remodeling stage, meaning that they were either resorptive, formative, or maybe having a mixture. So basically, we could see also that as this resorption progressed, you might experience that the pores even become or starts to merge into each other, forming very large cavities. And we found these cavities in the periosteal bone, but it's in particular also in the industrial bone. And this is also and this is what we think explains why we have this industrial tuberculization, that we'll see these enlarged eroded pores starting to become a part of the trabecular bone instead of the cortical bone, called this tuberculization. So that was sort of the main topic of this paper, that we did this analysis based both on a micro-CT scannings and then the histological analysis. They go hand in hand, so to say.
Yeah, for me, it was very interesting, and I like it when I saw that the paper is carefully using the same region for both micro-CT and immunohistochemistry. So it gives you a better picture of what's happening in the journal. And it was very interesting to find out that you said that industrial pores were reflecting the pores, remodeling of existing pores. And I found it that's really interesting to know. So I want to ask you, before you start this study, what was the main outcome of this study that you didn't hypothesize before? Like, what was new for you and exciting, not expecting before you start this study?
We didn't know if we could see this connection from, as I said before, we found that you will have these accumulation of eroded pores all over your cortex, but that we could see that in particular can explain this tuberculization, in fact, by this formation of pores or creation of pores, actually not going into formation, not to but you know that you will have this you will have these large number of eroded pores coming into larger cavities, and that you can start seeing some of these pores, they do actually become infiltrated with bone marrow. So that's a natural step of converting the cortical bone into trabecular bone. And you can, in some of our images, we can even see that it has been cortex before, because we can see the osteons in some of the trabecula. So you can sort of, even though you only have one section at one specific time point from one patient, you can see a little story in the bone and see that that must have been the way it happened, because yeah, it's still visible in the sections, and that make us also quite confident that we must have a very important link in this reversal resorption phase. Because if you're not, or if you cannot go from resorption into formation, you have a problem, obviously, because then your pores become larger. And this is a study in aging people, or as a consequence of aging, but this is also very important when you look into pathological conditions, because if that's the missing link, one could say we need to put more attention into this, because that could maybe help us develop future therapies within osteoporosis, whatever it could be related to bone. So that was nice to see that our theories were actually true also with that specific aim.
Yeah, that's right. And I can imagine, and you kind of mentioned that, but what were the main challenges you encountered with this study, and how did you overcome them?
Well, it's always a challenge to collect human biopsies. We have a nice and tight collaboration with a lot of surgeons at our local hospitals and in hospitals in Denmark as well, and that make it possible to have these samples, because it's a very nice thing for us that we can go in the human samples directly and look at these remodeling events and see what is going on. So that's one of the major tasks. But when that is done, we also experience that this thing of choosing the right angle, making sure that you can have this angle still when you do the histological cutting, that's quite difficult. And if you don't succeed, you're not able to compare your image with your section. But we found out how to do it, and I'm really glad, because I think it's a very nice and decent way to link our scanning data with histology, because in my opinion, it's needed, because we cannot detect everything with scanners. We can see the canals, we can see how they progress and all that, but we cannot explain why it is so. That's why histology goes so nice hand in hand with micro-CT, at least in my opinion. So we managed to do that, but you should be careful when you cut your sections.
I agree. That's a hard job, but you did a very nice job there. Well done. Christina, what do you expect the outcome of this study be for future research, or for translating into treatment or diagnosis of osteoporotic patients?
Well, I consider this paper and also our previous paper as a critical step in this understanding of how our remodeling is changed with aging, but also in particular in pathological conditions. And we have already, this study is done in one could say rather limited number of biopsies, but we have already expanded our cohorts and are currently working also with femur fracture patients, with femur fracture patients having osteoporosis, and they should be compared to healthy controls, age matched, so we can go and look how is the situation, is it comparable, what is the difference when we look in healthy aging people compared to osteoporosis, our patient with osteoporosis. And we're also going to look in further details for why is it that we see these differences. Is it due to the vascular structures? Is it the recruitment of proliferatives and the proliferative cells, number of proliferative cells? Because we need to ensure that we can go from absorption into formation, and that demands a team of osteoblastic cells. So we're trying really to set up a larger, or a number of larger studies to go into details with these questions.
Look forward to your future papers. What is your experience publishing in Bone Journal? Bone is one of the main journals in the field of musculoskeletal. So how was your experience?
I have only good and positive experience with Bone. I've published in Bone before. Luckily, actually my first paper was published in Bone, and it's always a smooth process. You have a nice communication with editor and the reviewers as well. You have nice feedback on your work, and even though they might not agree to publish, you will always have a nice feedback, so you have the chance to improve your paper. So only positive experience from my side.
That's good to hear. And in terms of your career and future goals, how will this publication help you to achieve those aims?
Well, it's a step into this, the next step into this area of cortical bone, maybe also trabecular bone. We're going to expand, as I said before, quite a lot on the cohorts. We're going to look into men, women, young kids also as well, and all of the things that could be determining how the remodeling events is actually affected within, age, pathology, whatever it could be. We're also going to set up a larger study looking at bone metastases from breast cancer patients. So we're trying to do a lot of stuff with bone now. And this is just some of the very baby steps into that area, I think.
Good luck. That's great. Thank you for taking the time today to discuss your work with us. We hope to hear more from you and your group in future. I would also like to thank the HubLE audience for taking the time and joining us today. If you would like to be involved in the Meet the First Other initiative, please feel free to contact us through HubLE. And finally, follow HubLE on LinkedIn, Twitter, YouTube, and Instagram. Thank you. Thanks, Christina.
Thanks, Neil.